Good morning, everybody, and welcome to the first webinar of the Seamless PV project. I'm Giulio Poggiaroni from ETA Florence. We are the leaders of the communication dissemination activities, and I will be chairing this webinar today. I'm joined by Elena Bosch and Juan Ignacio Martinez from Becquerel Institute. Becquerel is a partner of the project, and today we will do a deep dive into the market trends and regulatory frameworks for the four main sectors of the integrated PV domain. So agri-PV, BIPV, vehicle integrated PV, and infrastructure integrated PV. So before we start, I will give a very brief introduction about the Seamless project, which is an initiative funded by Horizon EU. Briefly, the objectives of the project, which is halfway now, still 2 years to go. It's the development of advanced and flexible PV manufacturing equipment and as well as manufacturing processes. This will lead to the development of a set of IPV products, actually 4, in different pilots across Europe that refer to those 4 sectors that I mentioned before. On the website, you can already find some interesting reports that were prepared by Becquerel on the market trends and the regulatory frameworks. These essentially are the subject of today. If you want to retrieve the text version, I encourage you to download them from the website. A few words on some other initiatives from the Seamless PV project. We launched last year the EU Solar Buildings platform, who wants to be a network, a platform for all the experts in the domain of BIPV, so one of the 4 domains previously mentioned. So building integrated PV, you can easily and freely join the platform, which is online, and there you can upload your BIPV realizations and actually also BIPV products. This is meant to be a showcase for BIPV products, create a network, put in touch different expertise across Europe, and also connect the architecture and the PV sectors more closely. Another big and important initiative of the Seamless PV project is the Integrated PV Conference. We held the first edition last year in 2024 in Florence, and we are back this year in Florence again in November with the second edition, which we hope it will be larger and way more interesting than the previous one, since we want always to improve. The first year was a success. We managed to gather more than 200 stakeholders from the PV sector, construction and architecture sectors. And this year we will host the second edition again in Florence in a new and larger venue that we hope will meet your expectations. If you're interested, the information on the IPV conference are on the website. Registration and participation is free. And actually, until the 31st of July, you have time to submit an abstract. All the details are on the website. By submitting this abstract, if successfully evaluated, will give you the chance to become a speaker and be included in the program of the conference. So be sure to check out the conference website and participate in this event. So without further ado, we start with the topic of today. This will be the first of a series of webinars, and we hope to make a great start today. So without further ado, I give the floor to Juan Ignacio, who will introduce us the topics that we mentioned with regards to BIPV and integrated infrastructure integrated PV. So please, Ignacio, go ahead.
Thank you, Giulio, and thank you everyone for being here. So we'll begin with well, you can see my screen, right? Perfect. So yeah, we'll begin with the webinar on market trends and regulation for IPV. So here we will be discussing 4 main segments: BIPV, IIPV, Agri-PV, and VIPV, or Vehicle Integrated PV. So just as a quick recap on what is IPV, It's basically, it has dual functionality. It acts as a construction element and a solar energy generator device that creates synergies with multiple sectors in order to accomplish the main function, which can be like noise reduction or agricultural activity, and also electricity generation. Also, it offers enhanced aesthetics and more design flexibility. In the case of BIPV, there's many types of applications. We divided them into roof and facade applications. First, for roof, we have simplified BIPV, which is not really BIPV in the sense that it's only the mounting structure part that is being integrated, not the module itself. Then we have discontinuous BIPV, which is mainly solar tiles and also skylights. For facades, we have a curtain wall or a warm facade, a rain screen or cold or ventilated facade. We have insulating facade cladding, and then we have also balustrades and other accessories that could go on the building envelope. So for the regulatory framework of BIPV, BIPV is covered under both international and European standards. And they pretty much define BIPV as a dual functionality element that if you were to replace the BIPV element in a building, you will need to replace it with a conventional product. So that is kind of like the definition that is being handled here. And it covers, and since it acts both as a construction and electrical element, it must adhere to those requirements as well. This is a quick overview, a quick glance of the requirements to apply for BIPV product and system. So yeah, you have the construction requirements that like the mechanical resistance, safety in case of fire, the low voltage directive in case of electricity. And yeah, it must adhere to all of these construction and electrical requirements. You don't see the presentation, Arthur? I don't know, Julio or Elena, can you see the presentation?
We see it correctly. So
Okay.
yeah, please go ahead.
Okay. And yeah, these building standards or codes can change between countries. Some countries are more strict. And here is a quick overview on how this can actually limit the application of BIPV. For example, in countries like Denmark, Germany, and Switzerland, buildings from a certain height require a fire reaction classification of A2S1D0, which means a virtually non-combustible material that also doesn't generate smoke and also doesn't create particles. So that is very hard to do for BIPV, and most systems only go up to classification B. So that would make them unavailable, unavailable in these types of surfaces or applications. In France, basically you need a technical approval for PV systems if you want insurance. So in practice, that makes it mandatory. And PV is not covered by the standards, by the national building standards in France. So you need another evaluation to prove its suitability. So that also complicates it more. And also, yeah, the fire safety class can be quite high in certain types of buildings. That is not to say that there's not incentives or targets that are pushing BIPV adoption across Europe, namely financial support, grants, and subsidies specific for BIPV are given in a limited number of countries. For example, I think Switzerland and Austria are the two biggest ones that are supporting BIPV. Switzerland has a specific policy supporting BIPV facades with the tilt angle bonus that it has. Then there's a general PV support, which are like feed-in tariffs, net metering, investment subsidies. And that is the most common form of support available in many European countries, and BIPV benefits indirectly from it. But this also faces some problems, as to apply for most of these grants or support schemes, like many countries are shifting or making it mandatory to include storage systems as well in your installation. Also, energy efficiency targets like the net zero and nearly zero energy efficiency in buildings are driving BIPV indirectly because it pushes energy renovations, which are one of the ways that BIPV is installed in buildings. So the BIPV stakeholders are many along the value chain, and we can highlight. We will highlight and explain a little bit the role of them in the next slide. Namely, the BIPV product manufacturer in the manufacturing stage, which needs to account the special requirements of BIPV modules, which can be quite specific, especially for facade applications, but also for roof, for each project. The architect in charge of planning and design, the construction engineering company in charge of installation, which needs to be specialized. And so what are the main factors driving BIPV adoption? There are the economic and regulatory factors, the economic motivation of increased value of real estate, incentives and subsidies, obviously, for energy generation, and the energy targets in terms of environment and innovation as well. Sustainability, to reduce CO2 emissions, green certifications in certain countries as well, and corporate responsibility. Then brand and social perception. We have the corporate and client image, if you have a green building, it improves brand image as well. And design objectives is to pursue, transmit a message of sustainability through your design. Then on technical and performance drivers, we have also innovation, changing building standards, which can become more rigid or more strict in the future. And with BIPV, you're basically protecting yourself against future measures or future mandates that require higher efficiency ratings. So the BIPV market will continue to grow over the next years, although moderately, since BIPV specific incentives are rare nowadays, as that was not the case in the early 2010s, that we saw a big boom in countries like France and Italy. Rooftop BIPV will remain the more popular option, but there is an increasing interest for facades. Yeah, and no major boom is going to happen as BIPV will continue to mimic the growth trend of BIPV a little bit. Technical requirements and standards are a major barrier in some countries, and the limited activity especially in the construction sector for new buildings, can also indirectly affect BIPV, as it would rely mostly on renovation activities, which can also be affected by other competing technologies, such as just a regular PV module. Okay. In terms of IIPV, infrastructure integrated PV, it is the integration of PV onto infrastructural objects, maintaining the primary functionality of the object in question. For this, in Seamless, we selected carports and also PV noise barriers, as they require specific manufacturing, not just the module on top of the structure. The cost sensitivity is also acceptable, and the technology is mature enough to have a realistic market potential. I want to make a clear distinction here that we are just strictly talking about PV noise barriers and not linear PV as a whole. Linear PV is like vertical PV along transport infrastructure with panels installed along roads or railways, but with the main function of generating electricity. Whereas PV noise barriers, or PVNB, the sound reduction is the primary functionality with the added benefit of electricity generation. For PVNB, we have many types of arrangements that can be made, including the cassette arrangement, the combined solution, on top solution. And we see here that bifacial modules are becoming increasingly popular for vertical solutions. But overall, the inclined solution is the more used one, as it generates better yield overall. For carports, we have them both in commercial and residential. Yeah, there's with different size of projects. In terms of regulation, PVMB also has no, or IIPV has no definition per se, but there are mentions of specific cases that vary per country. But overall, the requirements for a PV noise barrier are you need the PV requirements, like the electrical performance, and also the noise barrier requirements, which include acoustic characteristic, safety-related requirements like fire resistance, sustainability requirements, and CE marking requirements. For carports, there is regulation in two countries, in France and Germany, that supports the expansion or the adoption of PV on carports. And in the case of France, it's a national mandate for carports of a certain size, and it states that they would need to cover a certain amount of the area overall. And in Germany, it is a regional. Those are regional mandates that vary in between regions, of course. Like we can see, for example, in Lower Saxony, it's over 50 spaces, whereas in Hesse, it's over 35 spaces, and only for state-owned carports, if it's a private, it's over 50 spaces. So the regulation changes or varies per country and per region. Here, this is a brief overview, a quick glance of the key IIPV stakeholders along the value chain. Here we'll explain a little bit. So, of course, the product manufacturer needs to account for all the requirements, the noise canceling requirements, the shading requirements at hand. The project developer is engaged in the creation of the technical model, as well as preliminary studies and energy gains and cost considerations. And also operation and maintenance is a big deal here, and it depends on the specific companies or how the specific, for example, in noise barriers, how that is handled. But it's usually the road or rail managing company that is in charge of operation and maintenance. So what are the main factors driving IIP adoption? We have some policy and regulatory motives. We have like regional and national mandates in some countries, like we saw for France and Germany. And that it also aligns with EU decarbonization and noise reduction targets in the case of PV noise barriers, as the European Noise Directive has the goal of reducing noise pollution in Europe. We have economical and technical aspects, which, I mean, these are proven technologies. PV noise barriers have been around since 1989, and carports have been around for a while as well. And yeah, the electricity revenue and possible funding that you can get from this. For example, in Switzerland, since last year, the lease for those areas for PV noise barriers are completely free. So you only need, I mean, a company can go and apply for a tender there and build their PV&B, and also mobility trends and land use. So it aligns with the integration with EV infrastructure and the utilization of existing infrastructure, preserving natural and agricultural land. So what are the trends for IIPV? Like I said, these are mature technologies. PV&B remains highly concentrated in only a number of countries, whereas carports are only directed in two so far. There's a strong synergy with EV infrastructure, and the current PV&B capacity is estimated to be around 15 megawatts, which comes from mainly big projects and not like a large number of installations. And the outlook for this is that, well, there is a massive potential for carports in Europe, and the regulation needs to be either more strict or more supportive for this. Unlike the massive potential for vertical PV, which some of you may have read a report made by the JRC that it's over 400 gigawatts, PV&Bs is not as significant because they are not as extensive as, I mean, they are only concentrated in certain regions, in certain places of the road infrastructure. And yeah, I wanted to highlight the regulatory support and inclusion of IIPV as part of the energy strategies of countries is a key for these technologies to expand and grow in Europe. The potential for carports that we have estimated is between 60 and 100 gigawatts by 2050, or 10 and 13 by 2030. And for PV&B, the potential could go as high as 370 megawatts by 2050, or 34 to 39 by 2030. Elina?
Yeah, thank you, Juan. I will now move on to other sectors of integrated PV, agrivoltaics, and
yeah, no, sorry, Elina. I was just want to say
Yes.
to the audience that we will reserve some time at the end for answering the questions. So if you would like to do some, please use the Q&A tab that you find here on the Teams layout. So please, Elina, go ahead.
Thank you. So in agrivoltaics or PV systems in agricultural areas, to put it more broadly, there are also several configurations that exist. So you'd have on the top left ground-mounted PV with grazing, which resembles to a large extent to conventional ground-mounted PV, with some adaptations being made to accommodate, for example, the presence of livestock. So in terms of making sure that there are no sharp edges covering the wiring and cabling, and some adaptations in terms of the height of the systems, but where the PV production remains at the center of the project. On the top right, you have two possibilities where the agricultural activity is being conducted in between the rows of PV arrays. So in this case, the adaptation of the PV system to the agricultural activity is mainly in terms of space between the rows to accommodate the agricultural activity, but also the presence of agricultural machinery and equipment, where the PV system can be either ground-mounted tilted or also being used as vertical fences or vertical bifacial PV. On the bottom left, two typologies of agrivoltaic systems where the PV system design is even further adapted to the agricultural activities. In this case, it's mainly in terms of height, since the agricultural activity is being performed underneath the agrivoltaic systems. There can be some adaptations in terms of either PV module or PV cell density, and the presence of a tracking system to further align the light management with the particular crops that are being cultivated underneath. And finally, last category would be PV integrated into greenhouses, where here as well the PV design is being adapted mainly in terms of density of the PV cells or modules, again with the objective to have desired light input on the crops. So in general, one can make the distinction between two meta-categories. One would be PV on agricultural land. In this case, there is a PV plant with some form of agricultural production or activity around it or in the area, but with a focus or a dominance of the PV electricity production, should it be in terms of revenues, in terms of land occupation, And these type of PV system typically would only be eligible in tenders or any available support scheme in a country that conventional ground-mounted PV would also participate in. And then what we can call agrivoltaics, where the PV plant complies with specifically defined criteria which aim at ensuring a certain balance between the agricultural production and the PV electricity production, a balance in terms of land occupation, in terms of revenue, in terms of how the design is being defined. And in this case, those definitions for agrivoltaic are included in regulatory frameworks and hence often associated with specific subsidies. So there are here two examples of national regulation for agrivoltaics that I would like to present. The first one is here in France, where we can find again these two categories, PV on agricultural area on one hand, and then agri-PV on the other one. So in general, PV on agricultural area would be prohibited with the exception of very specific conditions or very specific cases. And this is when the area is or has been unused or uncultivated for a certain amount of time, or when it's in direct vicinity of buildings or abandoned area. And in this case, there are no specific subsidy or support scheme for these type of PV systems. And then on the other hand, what is being really defined as agrivoltaics are systems which follow four main conditions. First one being that the agricultural activity should remain the predominant one in terms of land use. That once we have the agri-PV system, there should still be a significant agricultural production. So that means more than 90% of what would be the case without an agri-PV configuration. The notion of service provided to the agricultural activity is also really key in the definition, and the service can be different types of services. So either there's an improvement of the agronomic yield or of the animal welfare, or the agri-PV system helps to mitigate climate change related risks and hazards. And finally, reversibility is the last defining part for agrivoltaics. And under these conditions, there are specific subsidies available. And then in Italy, it's a bit the same general logic with all the way to the left, PV on agricultural area, where the general rule is that it's prohibited with the exception of, again, some very specific areas near industrial or road infrastructure or transport infrastructures, abandoned land, former mines or quarries. An intermediary definition introduces some criteria with regards, again, to the agricultural activity dominance in terms of land use, and related to that, solar module coverage rate should not exceed a certain percentage. There's also a requirement in terms of the yield for both activities, where the PV production should be, again, at least a certain percentage of what it would be for regular PV, and agricultural production should be maintained. And then going one step further, advanced agrivoltaics have been defined as well, which rely on these same 4 points of agrivoltaics, but introducing even further criteria, one of which is related to height. So, for example, if it's agrivoltaic combined with crops, a height of at least 2.1 meters should be respected. And there are also requirements with regards to the regular monitoring of the impact of the agri-PV system on the agricultural area. So in terms of fertility of the soils, water needs, resilience to climate change. And these all provide the definition for advanced agri-PV, which are eligible to specific subsidies. In the agri-PV value chain, you would find conventional PV stakeholders, so project developers, installers, conventional PV module manufacturers, which can be implemented, but then also some stakeholders which are specific to the agri-PV sector. And so that could be actors manufacturing either specific modules or mounting systems or tracking systems and algorithms. But then we also have agronomists and farmers. And so on the next slide, one can see that these agri-PV specific stakeholders really have a key role in ensuring that from the manufacturing of the product and the systems all up until the installation and running of the project, a balance is being kept between both activities with win-win situations where the agri-PV system allows to bring in some added value to the agricultural activity. Key drivers for the agri-PV market can be summarized in 3 categories. In 2023, survey was conducting among about more than 200 farmers in Germany, and really what stood out from the survey was that what would be expected by an agri-PV system from farmers are, on one hand, adaptation to climate change, so it can be protection from sun or hail or rain, but also a diversification of revenue streams. And these 2 points can only be achieved with specific technical requirements for agri-PV systems. In terms of policy and market, agrivoltaics are also recognized as a potential key contributor to achieving renewable energy targets, especially in context where competition for land use is particularly fierce. And there are also some incentives and subsidy in some countries. And finally, there are many mature technologies and a broad range of design options from these technologies in terms of height, in terms of power density, which allow to then accommodate to also the variety of crops and agricultural activities. Currently, because there are no common definitions across all European countries, even in some countries there are no specific definition, it's quite difficult to make a sound estimation of what is the current market status. 1 year ago, Solar Power Europe estimated close to 3 gigawatts of agri-PV project, but this would be grouping all of types of PV on agricultural areas. But recently, across Italy, Germany, France, for example, which have developed specifically in the last few years, specific framework for agri-PV. There are many projects in the pipeline. Recently in Italy, 1.5 gigawatts of agri-PV projects were awarded in the dedicated tender. So it's expected looking forward that the sector will take off also as it's being more and more recognized as a key in reaching PV deployment target. There has been some concerns or acceptance barriers about agrivoltaics, but these precise regulation setting criteria for agri-PV development help mitigate that. And we conducted potential assessment for agri-PV where even under a strict regulation scenario, so that means only allowing or favoring agri-PV, which really allow to develop synergies between the two activities. The potential is still huge, even under these strict constraints, with 1 terawatt in 2050. Now moving to VIPV, again, rapidly going through the different typologies of how PV can be integrated into vehicles. First ways would be on passenger cars, so typically on electric or hybrid passenger cars, where the integration is predominantly made on the rooftop. So either as seen on the right images, integration into a panoramic roof, or rather on the left, a broader integration covering most, if not all, of the areas of the vehicle. So there are some challenges still for this type of vehicle typologies, which can be related to curved areas, and also the fact that in general available areas are relatively small compared to other type of vehicle, and that driving patterns are very diverse and can be subject to shading if they're circulating in urban environments. Then we have also possible integration in commercial vehicles, where it's also common to have it or possible to have it in non-electric vehicles. So that would be ICE vehicles, which are, for example, refrigerated, or where the PV production serves auxiliary services. The presence of large and flat area is a great advantage that this typology of vehicle presents. And also there's a general lower need for seamless integration, where aesthetics are not so important, and where for brand images one can even imagine that it may be relevant to make the integration visible. And finally, we have buses, where a bit the same trends are observed, where the flat horizontal surfaces makes the integration quite relatively easy, and where also compatibility with ICE vehicle is possible for onboard appliances, ventilation, and so on. Of course, one can imagine that PV integration on other types of mobility is also possible, planes, trains, boats, but those are not presented here. They remain quite even more niche. In terms of regulatory framework, there are no specific yet regulations for VIPV. The IEC is currently developing standards for VIPV system, which would address aspects related to safety, durability, performance, and testing procedures. But in general, the VIPV sector is driven or framed by regulation that apply for either vehicle in general, or more specifically on electric vehicles, and same goes for subsidies. There are no VIPV subsidies existing, but since most of the VIPV sector can rely on electric vehicle market, any subsidy for electric vehicle would also drive VIPV technologies. In the VIPV value chain, one can find automotive, conventional automotive stakeholders, from designers to assemblers, but then also specifically VIPV product manufacturers as well. And on the next slide, again, there's this idea that the combination of actors from the vehicle and the PV sector allow to eventually overcome or work on technical challenges or visual challenges that may be associated to the integration of PV into vehicles. The main driving forces for VIPV market can come from a wish or strategy of differentiation or corporate image, but also based on sustainability. To a large extent, and especially for passenger cars with PV integrated, there is a great correlation or a drive coming from how the electric vehicle market develops, and in general how the vehicle sector needs to align with emission targets and policies. And in terms of design and technical drivers, more specifically, one can mention the technical advantages or added value of having extended driving ranges, and then more on the design part, a premium feature which in niche luxury car segments can also drive the market. So as of now, the VIPV market is extremely limited. There are still a few challenges that the sector faces, which prevents broader adoption, still higher costs, and some technical challenges which can remain to integrate solar cells into vehicles. Also, there's been battery energy density improvements which have allowed to increase driving ranges, or the spread of ultra-fast charging stations is also a bit limited or minoring the interest that one would have of having solar PV to extend driving ranges. And finally, and again, especially for passenger cars, the benefits can be difficult to estimate and predict because it's highly dependent on the driving and parking patterns. So the added value from an economic point of view is more difficult to communicate on because it's very case dependent. But in general, looking at the potential for this sector, we expect that light electric vehicles would be a huge part of the potential, despite lower areas per vehicle. It represents an enormous vehicle fleet where electric vehicles have already an important penetration and nice dynamics. And then light commercial vehicles would be the second most promising segment, where you have still relatively large fleets and greater surfaces and perhaps even technical, more easy surfaces than for light electric vehicles, with the possibility to make combinations also with ICE vehicles, or even have the integration as a retrofit option. And the heavy-duty vehicles represent lower number of vehicles overall, but they have on the opposite advantage that the areas can be very important, even more so if also the sides of the vehicles, of buses, of trucks are covered as well. As Joe was mentioning at the beginning of the presentation, there are many more details and countries covered in those two publications, which are available on the Seamless PV website.
Thank you, Elena. I also thank you, Juan Ignacio, for the presentations. So we have some time for a few questions. So for our attendees, please, if you have some questions, use the Q&A tab. In the meantime, I will perhaps break the ice. We'll get back to Juan Ignacio. When you were showing the numbers about the BIPV installation, I wanted to ask you if you have some indications on the who are the driver, who are the subjects actually installing. Is this household driven, or it's more driven by, I don't know, construction companies and similar entities? Do you have such data?
As of today, not many countries report specifically on BIPV data, so most of this comes from estimations or previous reports. Only Switzerland makes a clear distinction between what is residential, what is non-residential on BIPV, and only Switzerland and Austria report on BIPV. But overall, the residentials, like across Europe, the residential sector is more significant, especially due to past regulation in France and Italy. But yeah, like most of these are estimates, and yeah, the residential sector is driving it.
Okay. So the residential, so probably household-driven push towards this. And from what I saw also from the contributions at the last IPV conference, it's a market where there is a high degree of modules customization, right?
Yeah, exactly.
Okay. Then perhaps a similar question to Elena with regards to AgriPV, since you mentioned a survey that was conducted. Do you see a drive mostly from big utilities or from agricultural companies? Could be either small or medium or large, because at least in the Italian case, we have seen that there is a large push from big utilities, especially for big plants, while on the agricultural side, so from the farmer side, there are many more difficulties and hurdles.
Yeah, well, on the stakeholders aspect, we see both. There are either agri-PV specialists, stakeholders, but also actors which have been developing conventional ground-mounted PV for years, which have been or are also entering the agri-PV opportunity. I believe in the last Italian tender in December 2024, there was a large participation of what they call agricultural companies. So also showing that for these more advanced agrivoltaic PV system, it's not purely led by conventional PV actor, but that there are also from the agri-PV sector interest demonstrated in those bids that were submitted. So we have a bit of both. And beside stakeholder typology, it's also clear that, well, globally, but also in Europe, that the market is significantly pushed when there has been specific regulation put in place. So in Europe, that would be mainly, yes, Germany, Italy, France, which are expected to drive the agrivoltaic market on the short term. Globally, it has been in Japan, China, and the US. So anywhere where a clear framework has been put in place, some market drive was seen afterwards.
Okay, thank you. There is a question on BIPV. So why did BIPV adaptation had a lull in the market during the years 2016, 2018? So probably it's referred to the graph. Yeah. Is there any explanation for this decrease?
It's because the support systems, I believe, of Italy at that moment, that was one of the main drivers, was phasing out at that time, the specific BIPV incentives.
It can also be indicated that since well, in general, in the absence of BIPV specific regulation in most countries, the BIPV sector also follows the general dynamics of the distributed PV sector. And so the general trend from 2015 to 2024 is also highly correlated to how the European PV market as a whole developed in those years.
There is a comment, but I'm not sure how to interpret if the graph includes both BAPV and BAPV, which I'm not sure what is referring to.
Yeah, well, this graph is only, if it's talking about this graph, it's only about BIPV. Distributed capacity or BAPV capacity, yeah, building applied. It's not included here. It would be much, much bigger. And those are generally reported.
Okay, thank you. Then another question, how does the BIPV market break down between facade and in-roof?
And a specific breakdown is not available, but Becquerel Institute, based on previous projects and previous work, and also interviews with stakeholders and companies, manufacturers and installers, has an estimation over the years of kind of like the share between roof and facade applications. But it's not widely reported, but there's public databases like EURAC, which lists some BIPV projects, which you can check.
Okay, thank you. Okay, there is another question. Could you list BIPV killing applications so far in Europe? Example, balcony solutions, colored facade, etc.
I'm not exactly sure what it
Yeah,
means,
me
BIPV
too.
cleaning, BIPV killing.
Yeah, okay. Perhaps I want to add another question for Elena, or perhaps on VIPV, which I believe is the most niche in this presentation that we have seen now. I see that there are quite some issues at stake, and you mentioned the fact that for heavy duty vehicles it's complex because the number of vehicles is limited, so the market potential is consequentially limited. But can be this seen as a important way to uh, improve the capabilities of the light commercial electric vehicles? Because I imagine that there will be problems in terms of the infrastructure, so providing enough larger infrastructure for recharging these electric vehicles. Uh, can be this a potential advantage of installing PV over electric vehicles, or even retrofitting the ICE vehicles? You're muted, sorry.
Sorry, commercial vehicles, and even more so for heavy duty vehicles, have the technical advantage of having relatively flat surfaces, and which can well accommodate a PV integration or application, even in some cases. And the more regular or predictable the driving pattern is, and especially if it's not in a dense urban environment, this creates a nice visibility on the possible cost advantages of having while driving charging, basically, but also extending the driving ranges, which can to some extent compensate for lack of charging infrastructure in some countries. While on the other hand, for light electric vehicles, the technical complexity may be a bit higher, although for example, panoramic roof, you already have laminated glass, so it's more of accommodating the automotive lamination process and the PV lamination process. But there, the variety in driving patterns and also the relatively limited area if you only use the panoramic roof may diminish a bit the advantage or the added value in terms of extension of driving ranges, but it all comes down to the balance between the added costs and the added advantage, which at least now still need to be defined or assessed on a case-by-case basis, depending, yes, on the mainly the driving and parking patterns.
Okay, we are almost at the end. We have two more questions. Do you have any recommendations on how to improve the regulatory framework for BIPV in Europe, especially regarding fire safety requirements and testing or different national building codes? I don't know if you have developed something like recommendations at Becquerel in this regard.
Sorry, can you repeat the question again?
So if you have any recommendation to improve the regulatory framework for BIPV in Europe?
Elina, do you know?
Well, one main barrier is also the diversity of technical requirements for BIPV product, which for a company developing a certain BIPV product makes it quite difficult to easily enter a new market and understand what are the requirements there. So really the diversity is an important barrier. Yeah, that would be.
So perhaps the creation of a European-wide standard would be of great help, I suppose. Okay. There is a question about the fact that BIPV products are quite expensive. Could you talk more about? Well, I think now we don't have time to discuss the impact of China, but as far as I know, that the one thing is that also BIPV is a lot, in many instances is custom made. So of course, this increases the cost if you want to have PV models custom made for your own house. So this, of course, increases the cost. But
there is also, as part of BIPV, specific mounting structure which allow to use conventional BIPV product or BIPV modules, PV modules, sorry. And in this case, because it uses conventional modules which are less expensive, the overall system cost would be cheaper compared to, yes, as you were saying, very customized BIPV discontinued roofing, for example, or skylights, where also the aesthetical added value of seamless integration comes also at a cost. So there is a great variety and range also in terms of costs among the BIPV sector.
Okay, thank you. Sadly, we have come to the end of our webinar today. I would like to thank you, Elina and Juan Ignacio, for their availability and insightful presentation. I would like to remember that the recording and the presentations will be available very soon on the Seamless PV website. And once again, I encourage you to browse through the website to check for the reports that were mentioned before and many other materials, as well as joining the EU Solar Buildings platform and check the upcoming IPV conference in November 2025. So thanks again to our speakers and thanks to all the attendees that participated, and see you next time in another webinar. Goodbye.
Thank you all.
Thank you all.